Hey students, thought I'd start a video solution here. People are asking about number 57 here. All right, so it says you have an old light bulb that draws only 50 watts rather than the original 60 watts due to the evaporational thinning of its filament. And so a light bulb looks something like this. It has this thin filament here. Maybe the glass bulb looks something like that and has a little screw in with a knob. And so there's the bulb. And so this is made out of tungsten, and after time, pieces evaporate off of the tungsten. In fact, they cool on the glass surface. That's why you can kind of see an old bulb, and it kind of has a smoke or a dark tint to it. That's an indication that the tungsten has evaporated off and now is beginning to condense on the inside edge of the glass. So when that starts to happen, the filament changes its diameter and its resistance changes, because remember, the resistance is related to the area, and of course the area is pi r squared. Okay, so what they're saying here is that it got thinner and there's more resistance, and because of that there's less current. See, the power is current times the voltage, or another one is V squared over R. Of course, another one is I squared R. But let's focus on this one for a moment, because when you plug in the light, the voltage doesn't change. It's 120 volts. As the resistance changes, that changes the current, and of course, the resistance changes too. So it would be nice not to write, let's see, this one, because both of those are changing. Here, that's not too bad because only the current is changing, but the current is related to the voltage, so we would have to say V over R, which is that. So with that in mind, and using any of these three options to talk about the power, I'm going to use the V squared over R. That way I can talk about how the R is. So they say it's the original light bulb. Okay, so the original light bulb would be 60 watts, and it would be plugged in. They don't really say what the voltage would be. It just says an old light bulb draws 50 watts rather than the original 60 watts due to the evaporational thinning of the filament. By what factor has the diameter been reduced, assuming it uniformly thinning along its length? Neglect any effects caused by a temperature difference. So I'm going to go with the assumption, and I'll put a little resistance nu, that they're plugging it into some fixed voltage. Like if this was North America, I would say it's 120 volts. If it's an AC circuit, of course, I guess it could be plugged into the car, so it would be a standard 12 volt. So there's a lot of options here, but it's probably, in my mind, I'm thinking this is 120. But it really doesn't matter, because then let me write off that same equation, but I'll say resistance when it's old. So N for new and O for old. So then if I, swap these out, if you will, or maybe I move R new to that side and R O to that side, they each equal V squared. So if that's a constant voltage source, again, like a wall plug, you're saying that the resistance of the new times 60 and the resistance when it's old times 50 are equal to each other. Okay. Now, remember, the resistance when it's new would be rho times the length of the filament divided by the area, which, where did we say here, would be pi, and let me just write this as R squared, and I'll put a little n there for new. So that's the resistance when it's new. And then, of course, the resistance when it's old would be the material, usually tungsten, rho, its length, and they're saying that doesn't change. Pi, of course, pi doesn't change, but R, when it's old, has gotten smaller, times 60. So again, notice that the same material shows up, the same length shows up on both sides, a pi shows up on both sides. And the question is asking by what factor has the diameter been reduced? Okay, so maybe I'll simplify this and I'll, oops, my bad. That was supposed to be a 50. Okay, so I will cross multiply, and so this will be the radius squared when it's old times 60. And this over here would be 50 times the radius when it is new squared. And I want to know, let's see, by what factor has the diameter been reduced? So I want new times some number equals old. So why don't I move the 60 over and now take the square root? Because then I'll have radius of new times that thing. All right, so that would be the square root of 50 over 60, 0.91, 0.913. Okay, so the new radius, new radius, and then we take 91% of it, and we get the old one. Now, it depends how they want it. They might want it the other way around, like new compared to old would be 1 over 913. So we'll do the reciprocal and see what we get. 0.109. So they might say it's reduced by 9%. Although I guess we could have just done that there. All right. Hope that helps.